All right, so now we're on to our second learning objective in this self-paced unit. All right, so we're going to keep going with this inverse trig. All right, but now we're just going to make one change, and now we're going to use the unit circle in order to find exact values. All right, so this is basically what I just said. All right, we talked about how to find an angle using a calculator, and now how we can find these answers without using a calculator with kind of those special angles that we've been using a lot for sine and cosine. All right, so we're going to find the exact value of sine inverse of the square root of 3 over 2. So we saw in our first learning objective that if sine of theta equals some y value in unit circle, sine inverse of the y value equals the angle. So basically what this is saying is whatever's in the parentheses here represents a y value on the unit circle. And we need to figure out what angle is this equal to. Another way to think about this is we can always switch these things. This would be sine of theta equals the square root of 3 over 2. All right, so we're trying to answer the question, what angle has a sine value of the square root of 3 over 2. If we figure out the answer to this blue question, then that's our answer, because the angle would go here, which would complete that statement, which would be the answer up there. All right, so if we think about the unit circle, all right, on our last quiz, we had to figure out those values where those kind of 5 special angles hit the unit circle. But think about the y values, all right, like this point is not going to work because the y value of that is 1/2. And if you have that little picture memorized, you'll have to see that this point up here is 1/2 kind of square root of 3 over 2. And that angle, all right, we're going to be using radians in this video. That angle is the angle pi over 3. That's our final answer for this one is pi over 3. Because if I put pi over 3 into sine, I get the square root of 3 over 2. Which means if I put the square root of 3 over 2 into sine inverse, I get out pi over 3. All right, so this angle here that we were looking for is pi over 3. All right, so you're just looking at that kind of picture you had to memorize for your last quiz, and which of those angles gives you that value you want. All right, so now it's time for you to try your own. All right, find sine inverse of the square root of 2 over 2. All right, so again, take a second, think about this, and then I'll give you the answer in a second. All right, and the answer is pi over 4. All right, because if I put pi over 4 into sine, I get the square root of 2 over 2. All right, so again, if you have those angles memorized, you can kind of use those to get these answers. All right, but something goes wrong when we're kind of doing these problems. All right, for instance, we know if I had to find sine of pi over 3, which we just did earlier, that was square root of 3 over 2. But if I had to find sine of 2 pi over 3, I do that on the quiz as well. If you did all the stuff, you figure out it's a quadrant 2 and it's related to pi over 3. That answer is actually also the square root of 3 over 2. So this makes it seem like sine inverse of the square root of 3 over 2. If I'm going backwards from the square root of 3 over 2, it looks like I could get 2 different answers. I could get 2 pi over 3 or pi over 3. But we don't want that to happen when we're talking about any type of function. We only want to get one answer out. All right, so how do we fix this? We basically say we don't use every possible answer. We only use specific answers. What we're going to end up doing is not worrying about this and just worrying about that angle. All right, so the way we're going to fix it is if we have our kind of xy plane, how do we make sure sine inverse doesn't repeat answers? Well, sine inverse has to do with y values, and if we don't want y values to repeat, we're going to use this right half of the circle. All right, so any angle in the right half of the circle, all right, will be an answer for sine inverse. And we haven't talked about cosine inverse, but it's all the same stuff. It's just with the x values instead of the y values. So for cosine, we want to make sure none of the x values repeat. And to do that, we're going to use the top half of the circle. All right, so whenever we're doing a sine problem, we make sure we use the right half of the circle. Cosine, we use the top half of the circle. And we'll see exactly how to do that in an example right now. All right, so let's actually start off with this middle one, cosine inverse of negative square root of 2 over 2. All right, well, first of all, cosine is x values, and negative square root of 2 over 2 is going to be somewhere over here. All right, that's the x value, negative square root of 2 over 2. And my unit circle looks something like that. All right, so it looks like there's two different places where cosine is going to be negative square root of 2, and that's true. There are two different places it happens. But based on that last slide, we only care about the one on the top half of the circle there. All right, so we kind of ignore that bottom left one. It is a place where cosine is the negative square root of 2, but it's not going to be the answer for cosine inverse. And how do we actually figure out this answer? Again, you can use kind of some reasoning based on unit circle. When do we get the positive square root of 2 over 2, which is here? Right. We get that when the angle we're looking at is pi over 4. And we did this the very first time we started learning about sine and cosine in the unit circle, is we flip this yellow angle over here. It tells me that wedge in there is also pi over 4. So the red angle I care about is the half circle, going this way, and I take away this pi over 4, you get 3 pi over 4. And that ends up being my answer. All right, so for cosine inverse, I have to be on the top half of the circle. 3 pi over 4 is in quadrant 2, and if I plug that into cosine, I get the value I want. All right, so there's a little bit of using a picture to give you these cosine inverse examples. All right, sine inverse is actually a little bit better. I have my unit circle. Sine's y values, so if the y value is the negative square root of 3 over 2, it's a negative y value somewhere down there. And it looks like there's two answers, but we only care about the right half of the circle. We're just trying to find that angle there. All right, for all these negative answers, we're going to use the positive answer to our advantage. So we knew the positive answer was that the angle was pi over 3. And the easiest way to do this, and the way it's going to give us the right answer, is instead of rotating upward to that angle there, we just want to rotate downward to the red angle that we care about. So our answer is not going to be pi over 3, it's going to be negative pi over 3. And that's our answer for sine inverse. Negative pi over 3 is on the right half of the circle. All right, and it makes sure that if we plug it in, we get negative square root of 3 over 2. All right, so these negative negative values for sine inverse are going to give us these negative angles. Cosine inverse is a little bit different because we're going to use this left-hand side where the angles are still positive. All right, sine inverse of negative 1. Thinking about our unit circle. Negative 1 is just down here at the bottom. And if I want to go and rotate down this way to the bottom, that's going to give me negative pi over 2. All right, because pi over 2 is a 90-degree angle, but I'm just doing it in the negative direction. All right, so again, you can see the kind of pattern that the negative values for sine inverse give me these negative angles. All right, so a little bit going on. Cosine's different than sine, so that's one kind of difficult thing to remember. All right, but you have to remember that cosine, all right, is this kind of top half of the circle, and sine is this right half, where if you have negative values, you're going to get negative values out. All right, so to test your understanding, I go ahead and try this problem. All right, what is cosine inverse of negative 1/2? And you can see the answer. The answer is 2 pi over 3 because the positive answer is pi over 3. And if I go backwards from pi over 3, it gives me this actual angle, red angle here that I'm looking for, which ends up being 2 pi over 3. All right, so that's how you do it for these cosine inverse problems. All right, so again, the last thing, your multiple choice question. All right, select the correct answer for cosine inverse of the square root of 3 over 2. Again, once you're done with that, all right, go grab the practice problems for this learning objective and get started on working on the practice.